camera on? Is the camera on? Okay. Breaking news. Last week, a large meteor has crashed on Lapstar Island, fully demolishing the infrastructure there. All citizens are advised to fully evacuate from the island by order of the President. Hello?
Thank you, Mr. Chief, for safety.
This just in. President has released an official statement saying that he will start a rehabilitation plan to reduce radiation to 350 ppb by finding talented scientists. Stay tuned to BLC for more information.
Find the half-life to find the constant K. So then what order is this? Ilahi, what order is this? First order. Okay, good. And is it right here? Okay, everyone, class dismissed.
Dr. Mayfield from Leicester Federation. We need your help.
Sure, but first, let me get my thing.
It tastes good like soul food. Parked up outside in the old school. The new me back with the OU. The dog always find his way back home, and it's so true.
Good evening, everyone. Sit down. So, last month, I give you guys task to solve our poor island problem. Huge meteorite just fall to our island, and I want to know what is your progress. Play the video.
Okay, so recently there's a meteor strike at Lobster Island. So I'm gonna explain about the overview of our meeting today. Okay, so this is our table of content for today's meeting. Okay, so I'm gonna explain about what radiation is. So basically, radiation refers to the emissions of energy in the form of electromagnetic wave or subatomic particles. So and then radiation can occur naturally or be produced by human activities. In this case, it refers to the emissions of ionizing radiation resulting from the radioactive nature of the meteor that struck Lobster Island. Ionizing radiation is the release of high-energy particles of or electromagnetic waves that have the potential to remove electrons from atoms or molecules. So we already identified the radioactive, which is polonium-214. And it primarily emits two types of ionizing radiation, which is alpha particle and gamma rays. So for alpha particles, basically for alpha particles, it consists of 2 protons and 2 neutrons. Alpha particle is a positive charge and it is relatively large and heavy. The second one was the gamma rays. So basically, gamma rays is electromagnetic radiations of a very high frequency. Gamma rays don't have mass or charge, and it is highly penetrating. Gamma rays require thicker shielding such as lead or concrete to be stopped or absorbed.
How will this radiation affect our citizens?
Awesome.
So
So now we will be discussing the effects of polonium on the humans living on the island. So basically, there are three main effects which could affect a normal individual, such as cancer, mainly lung cancer, gastrointestinal complications, and systemic toxicity. So to elaborate more, when the radiation could damage the cells in a human's body, which could cause them to become cancerous, and the gastrointestinal complications, which means you could have issues in your stomach and have stomach pain and indigestion. And for the systemic toxicity, it could affect your tissues and it could pass in your blood and affect all of your body's organs, which could make you feel weak and dizzy and fatigued on the long term. Okay, that's it. Okay, so now I will pass the presentation to Alf.
So to investigate the radiation from the meteor that recently hit the Labs Island, we need to know what is half-life. So basically, half-life is the time required for the reactant concentration to decrease from its initial concentration to half of its initial concentration. So the faster the reaction, the shorter the half-life, and vice versa.
So this is how we will integrate the integrate rate law. So first of all, we will swap dt with the concentration, and then integrate both sides with, and then integrate both sides with time with 0, and time equals to t. And then after we integrate the equation, we will rearrange it, and we will have the integrated rate law.
Okay, that's all for our first research, Mr. President.
Thank you, Mr. Chess, for saving the Labs Island. Now I will release all the info to the press.
Good evening, everyone. Welcome back to BLC News. It has been more than 3 months since the island incident, and now we finally have word of the scientists that the president hired, and they're here now to give out information. Please, go ahead, Professor Osama.
So basically, there are three. Okay, thank you, Mr. Azzuddin. So now we will move on to calculating the final concentration of polonium-214 to establish a safe level. So now we have 16.8 millimolar of polonium. We need to convert it to molar. To do that, we will divide 16.8 by 1000. Now we have 0.0168 molar, which is our initial concentration. So the safe level we need to establish is 350 parts per billion in water bed. So we will take 350 parts per billion equal to 350 grams of polonium-214 divided by 1 billion parts of water. Our final concentration will equal to the number of moles of polonium-214 divided by a liter of water. So to find the moles of polonium-214 that we need, it will be 350 grams of polonium-214 divided by 214 grams of polonium-214, which is the molar mass. Now we have 1.6355 moles. We will divide this answer by 1 billion parts of water divided by 1000 milliliters to convert this to liters. So now we will have in our denominator 1 times 10 to the power of 6 liters. When we divide this fraction, we will have 1.6355 times 10 to the power negative 6, which will be our final concentration.
Hello everyone, Dr. Aini here. As for my part, I will explain how we basically determine the half-life of the sample we obtain, which is polonium-214. To determine the experimental value of radioisotope half-life, we record the mass of isotope every day using mass spectrometry every 15 days. Then we can plot graph of concentration in molarity. We also plot this lone concentration graph using the integrated rate law formula. So in here we can get the K value. So basically for the last step, just substitute the K constant into the integrated half-life and you will get the value of 15 days.
So you might be wondering how long it would take for us to restore Lobster Island so that it's safe for citizens to come back in. Based on our calculation by using the integrated rate law, we will sub in the initial concentration, the final targeted concentration, and the K value. It would take approximately 200 days to restore Lobster Island. And last but not least, Lobster Island will be reopening on the 25th of November 2023.
Thank you very much, our esteemed scientists. To sum up, most changes to the half-life of radioactive materials are minimal, and significant alterations require sophisticated and expensive equipment. In most cases, the half-life of radioactive decay remains relatively constant. Now, the residents can expect to move in back by 25th November of 2022.